Okay, we can convert back and forth between different systems. For example, suppose we had 1, 0, 1, 1 base 2 system. Sometimes when we write numbers, if I write a subscript down here, that's the base of the system. So this isn't 1011. This is 1011 in base 2. So what is the count that actually that represent? That doesn't represent 1011. So let's convert this. Convert to base 10. So probably the easiest way to do that is we look at each of these ideas and we recognize that this is the 2 to the 0 column. This is the 2 to the 1 column. This is the 2 squared, and this is the 2 cubed. What do I mean by that? Okay, let's think of a base 10 system and a number represented in base 10. So the way that works is this 3 actually represents the 10 to the 0 column, or the 1s, because 10 to the 0 equals 1. This represents the 10s column, or 10 to the 1. This represents the hundreds, or 10 squared. And this represents the thousands, or 10 cubed. So when you think of that like that, then it's just natural to think of a base 2 system in the same way, where this represents the base. We actually call this, when you're dealing with an exponential number, we call this the base number. So 2 raised to the 0 power column, this is the 2 to the 1 column, this is the 2 squared column, and the 2 cubed column. So what we could do then is we could just simply do the math here. So we could take 1, and multiply it by 2 to the 0. Then we could take this 1, we could add to that, this 1, and multiply it by 2 to the 1, and add to that 0 multiplied by 2 squared, and add to that 1 multiplied by 2 cubed. So then we just figure out what this equals. We do the math here. So in a base 10 way. So 1 times 1 is 1, plus 1 times 2 is 2. 0 times this, well, 0 times anything is 0. And 1 times 2 cubed. 2 cubed is 2 times 2 is 4 times 2 is 8. So 1 times this is 8. So 8, 9, 10, 11. So this represents actually 11. So 1011 represents a base 10 count of 11. Well, it's not just even a base 10 count of 11. It represents 11 things. It's just the base 2 writing. The base 2 description of 11 is 1011. Okay, now we don't have to be only in base 2 to do this. We can do this in any base. For example, let's try 1011 represented as base 5. Let's convert that. Let's convert that to base 10. Okay, so how many counts is that? So again, we have 1 in the 5 to the 0 column. We have 1 in the 5 to the 1 column, because now this is different. This isn't base 2 anymore, this is base 5. So this is the 5 to the 0 column. This is the 5 to the 1. This is the 5 squared. And this is the 5 cubed, because our base now is 5. Okay, come on, switch over. I add this to 0. This is 0 again. And 1 times 5 cubed. So 1 times 5 cubed, if you do that math, you're going to come out with 125 plus 0 plus 1 times 5 is 5 plus 1 times 1, 5 to the 0 equals 1. 1 times 1 is 1. So this is going to be equal to 131. So the same scripts used here, 1, 0, 1, 1, represents 3 different things in 3 different base systems. It represents 11 in base 2. It represents 131 in base 5. And of course, it represents 1011 in base 10. Okay, not only can we convert things to base 10, we can convert numbers that are written in base 10 to other bases. So, for example, we could write a count of 42 in base 10. I'll just put 10 down here, although we never do that. We always leave that off. But let's write 42 let's convert it to a base 2 number. All right, so the way I do this is, it's also shown in in Smith, this approach too, is I start down here with 42 and I will divide it by 2. So 42 divided by 2 is 21, and that's even. So there's a remainder of 0. So it's important to keep track of these remainders. A remainder of 0. There's nothing left over. It's even. Okay, let's divide this now by 2. Well, if I divide 21 divided by 2, 20, that's going to be 10. But there's a 1 remainder. So remainder 1. So now let's do 10 divided by 2. This is even. Goes into 5 evenly. So there's a 0 remainder. So when we divide 5 by 2, we get 2. 2 times 2 is 4. There's going to be a remainder of 1 here. Again, 5 divided by 2 is 4. There's 2. Remainder of 1. Okay, and then we'll divide 2 by 2. Goes 1 time. It's even. There's no remainder. Remainder 0. And then divide this by 2. Well, it just comes out to be a remainder of 1. So then we start from the top here and list these numbers as we go down. So 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. This base 2 equals essentially 42 in base 10. And that's how you do that. Okay, so if we were converting to a different base, we would just divide by a different number, but we'd use the same process. Okay, so this ends our topics in Chapter 1.